This tutorial is to walk you through a system of equations with fractions through the substitution method. So this will look similar to one of the problems in the group assignment, and I just thought I'd walk you through it so that you would understand and get a refresher on how to work with fractions. I'll do a second video, since substitution will take so long, on how to solve this one with the elimination method, since it's my preferred method. So I'm going to first give us a lot of room because we're going to need it. So the first thing is they've actually already solved for y for us, which is kind of nice. So we're just going to take this and substitute it in for our second equation for y. So I'm going to copy this and paste it here, and where y is, I'm going to put parentheses because I want everything that equals y to go in there. This helps with negatives and missing terms and things like that. So then I paste it in. All right, so now I have an equation right here that only has the variable x, and I can solve for that. To get rid of these parentheses, I need to do the distributive property. So I'm going to multiply the negative 1/4, and if you're not okay thinking of this subtraction sign as a negative, you can go ahead and change that to adding the opposite, which is making this and add the opposite like this. I prefer actually leaving the subtraction sign because I've done it for so many years. I think that when I put the add in there on the typing screen, it makes me miss the negative. When I'm writing though, by hand, I do change it sometimes to an add the negative, since the negative is up in the up here, but when I put it down here, I miss it. So I'm not going to do that on the screen. All right, so I'm going to multiply this in. I end up with a negative times a negative, which is positive. And when I work with fractions, I'm going to push Control V so that I get this in here. When I'm working with fractions, actually, I don't want that one. I apologize. I'm going to copy this one. No, we'll copy this one and paste it. Okay, when working with fractions, oh, that's still going to have these parentheses. Okay, we'll just delete all that and have to add it in. As a refresher, I multiply the numerator times the numerator and the denominator times the denominator. So this becomes add 1 over, because 1 times 1 is 1, 4 times 3 is 12, and I'm going to put a space bar, and I still have the x there, so I'm going to leave the x. Then I'm going to do the negative 1/4 times the positive 6. So a negative times a positive is negative, and I end up with a 6 on the top because I can change this to be a fraction, 6 over a positive 1. That makes it a whole number look like a fraction. So then I have 1 times 6 is 6, and then I have 4 times 1 is 4, and I get 6/4. I will be simplifying that in just a minute as well, but for now, it looks good. So on the left-hand side, I need to combine these two here with a common denominator. So I want the smallest number that both of them will go into. I know 2 will go into 12, so that will be my smallest number. So I only have to worry about the 1/2. To make it a 12 on the bottom, that means I need to multiply this by 6. And to keep the fraction balanced, I need to multiply the top also by 6, and so that it stays balanced, and I get 6 over 12. Okay, so I have here 6, and 2 times 6 gives me 12. And now I can add these together. I have 6 over 12 plus 1 over 12, which gives me 7/12. So when you're multiplying, you multiply the numerator times the numerator and the denominator times the denominator. When you're adding fractions, this is when you keep the denominator and you add up the numerator. So I have 7/12, and I can get rid of this, times x minus 6/4 equals 2. So I can change this to dividing both 6 and 4 by 2, which gives me 3 halves. Now I need to get the x by itself, so I'm going to take the 3 halves and add 3 halves to both sides. Add 3 halves. On the left-hand side, that will cancel out. On the right-hand side, we'll get there in a second, so this becomes 0. So I have 7/12 x equals 2 plus 3 halves. To add these on the right-hand side, I need another common denominator here. So let's get rid of these guys. So to get the common denominator, since 2 can be written as 2 over 1, the common denominator that's the smallest between those will be 2. So I need to multiply like I did before, top and bottom, by 2. And now I have a common denominator as 2. And I'm going to show this in the next step. Copy, paste. So I have the 2 on the bottom. 1 times 2 is 2. 2 times 2 on the top is 4. So I have 4 halves plus 3 halves, which when I'm adding fractions, that means I keep the denominator the same. I'm going to get rid of this. And 3 plus 4 gives me 7 halves. Now I need to take care of the operation between the fraction and the x. This right here is multiplication, which means I need to divide by 7 halves. I think this might, I want to show it as it's supposed to be. Okay, I'm going to put the x up here with the 7 just so I can show how we need to divide this whole thing. Divide by 7/12. There we go. So we end up with what looks like a complex fraction. And that's the term for it because I have a fraction divided by a fraction. So you need to remember that I can't divide fractions. I need to multiply by the reciprocal. So we're going to take our 7/12 x, here we go, and multiply it to the 7/12. Multiply the reciprocal, which is 12/7 x. Now the reason this works is that 7 divided by 7 is 1, and 12 divided by 12 is 1. So the only thing I'm left with on the left-hand side is the x. So copy and paste, get rid of everything but the x. So you end up with x equals, now I can't just do it on the left-hand side, I need to also multiply by 12/7 on the right-hand side. That way I keep my equation balanced. So on this right-hand side I have 7 divided by 7, which will cancel out, and we can show that again as we've done before by 7 divided by 7 is 1, so that's, I can put a 1 there. 12 divided by 2 is 6, and I like to divide first because it's just so much faster. Now that I have, oops, get out of that. Now that I have I need an equal sign in there, equals. Okay, so now that I have those divided out, 7 divided by 7 gives me 1, and 12 divided by 2 gives me 6. I'm left with 1 times 6, which is just 6. And that is the answer for x. I'm going to highlight that so that we don't lose it. Now I need to go back and solve for y, and since we have our very first equation already solved for y, I'm going to take this, bring it down here, and substitute in what I found for x in for the x, which is 6. And again, I'm putting in those parentheses so I don't miss any negative signs or anything like that. And like we've done on all of the other fractions, I'm just going to draw this in here. 6 divided by 3 is a 2, and I have this negative out here, so I have negative 1 times 2, which is negative 2. So we'll write negative 2 so I don't lose you visuals learners. The negative 2 plus positive 6 equals, move this over a little bit, equals, okay, so Negative 2 plus 6 gives me positive 4. And so now I have my y value. I'm going to highlight that, and I can rewrite this as an ordered pair. The x comes first, so we'll put 6 comma 4, close the parenthesis, and this is our solution for this system of equations. And because I got a solution and it makes sense, this is a dependent solution for the system of equations. I'll see you on the next one when we go through the elimination method on this same problem.